Hello everyone! Today I would like to give you a lesson on the topic the most difficult geometry problems, part 1.
Before starting to watch this video, don't forget to subscribe to my channel and like it. I will be very grateful to you for that.
Problem 1. The lengths of the sides AB and BC of rectangle ABCD are equal to 6 centimeters and 10 centimeters respectively. Point M is the midpoint of side CD. Point L lies on the side BC at a distance A centimeters from vertex C. For what value of parameter A does angle ALM equal 90 degrees? If there is only one such value, write it in answer. If there are several such values, write their product in the answer. And so I draw a rectangle ABCD. Its side AB, according to the condition of the problem, is equal to 6. AD equals 10. Point M is the midpoint of side CD, so CM equals MD equals 3. And we denote LC as A. If LC equals A, then BL equals 10 minus A. So we determine the value of A from the condition triangle ALM is right-angled. So here we will need the Pythagorean theorem, which says that AL squared plus LM squared equals AM squared. Next, first we take the triangle ABL. Here I'm highlighting it, and in it we apply the Pythagorean theorem. Here, AL, we have the hypotenuse. So AL squared equals 6 squared plus 10 minus A squared. Then we take the triangle LCM, and there too we use the Pythagorean theorem, which says that LM squared equals A squared plus 3 squared. Then we take the blue triangle, which I just highlighted, and also express there AM squared through the Pythagorean theorem. So AM squared equals 10 squared plus 3 squared. We take the triangle ALM, and in it we also apply the Pythagorean theorem. And instead of AL squared, I will substitute what we found on the previous slide. Instead of LM squared, I will substitute A plus 3 squared, and instead of AM squared, I will substitute 10 squared plus 3 squared. Then I will calculate it all, apply the reduced multiplication formula. We get 2a squared minus 20a plus 36 equals 0. Now I will divide this equation by 2. After that, we will have the corresponding equation. And if according to the condition of the problem, we were told that if there is only one such value, write it in answer, and if there are several such values, then write their product. So we must remember Vieta's theorem, which says that the product of the roots of a quadratic equation is equal to the free term, in our case, q, and q is b over 18. This number will be our answer. Problem 2. Given an equilateral trapezoid ABCD, BC parallel to AD, AD equals 5 centimeters, AB equals CD equals 4 centimeters, BC equals A centimeters. Determine all positive values of parameter A. In your answer, write down the number of all integers. Solution. And so I draw an equilateral trapezoid ABCD, denote that the base AD equals 5. The sides of the trapezoid will be equal to 4, and denote that BC is equal to A by condition. If A is any number, then there are some questions regarding this base. We will now consider several options for the lengths of this base. And so I drew an equilateral trapezoid in front of you, and I want to, first of all, note that this number A will always be greater than 0. In the second picture, I marked that the number A is equal to 5. That is, the base is equal to another base. Can this be? No. So I mark that A is not equal to 5. And in the third picture, I marked that A must always be less than the sum of the base and the sides of the trapezoid. So what exceptions do we have that this number a is in the range from 0 to 13 and it is not equal to 5? So in this range we have the following integers: 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. I counted that there are 11 of them in total. Therefore, the answer is 11. Problem 3. Two concentric circles are given. The radius of the first is 10 centimeters and the second is a centimeters. Determine all values of parameter a for which the area of the ring bounded by these circles will be 64 pi centimeters squared. If there is only one such value, write it in answer. If there are several such values, then write their sum of their squares in the answer. And so I consider two cases. The first case is that we are given a circle with a radius of 10, and the second circle will have a radius greater than 10. And in the second case, we will consider that we are given a circle with a radius of 10, and another circle is also given to us, but its radius will be less than 10.
And so let's consider the first case. We need to find the area of the ring which is painted in yellow. So to find its area, we need to subtract the area of the small disk, whose radius will be 10, from the area of the whole disk, which has radius a. We subtract, and we get that their difference will be equal to 64 pi according to the condition of the problem. So we divide everything by pi, and we have that a squared will be equal to 164. And so let's consider the second case. We are given a larger disk with radius 10, and we are given another disk with radius a. So now we subtract the area of the circle with smaller radius from the area of the disk with larger radius. We divide this whole equation also by pi. After we still divide by pi, we get that a squared equals 36. Now, in the first case, a squared was equal to 164, and in the second case, a squared is equal to 36. In the condition of the problem, we were told that if there are several such values, then write down their sum, and their sum is equal to 200. This will be our answer. Problem 4. Two parallel lines and a rectangle ABC lie in the same plane. See figure. For what largest integer value of parameter a is the triangle ABC isosceles, AC equals BC? And so we see two equal angles that are equal to 2 alpha degrees. Now, what we do is we denote the angle ACB x degrees. Now, we remember that the alternate angles are equal. So I denote that in our case, these two angles, they will be equal. So if angle MAC equals angle ACN, then angle MCA is equal to the sum of angles ACB and BCN. So I write that angle MAC equals x degrees plus 2 of alpha degrees. Next, we consider the triangle ACB. Note that this triangle will be isosceles, because AC is equal to CB. So the angles at the base, CAB and CB, they will be equal. And we can find them as, from 180, we subtract x degrees and divide it all by 2. So it will be equal to 90 degrees minus x degrees divided by 2. And what do we do next? We take the developed angle A, which is equal to 180 degrees. And it is obvious that the sum of the angles that make up angle A is equal to 180 degrees. So we make the equation. X degrees plus 2 alpha degrees plus 90 degrees minus x degrees divided by 2 plus 2 alpha degrees is equal to 180 degrees. We simplify this equation and get that x degrees equals 180 degrees minus 8 of alpha degrees. Next, so we have that x equals 180 minus 8 alpha. And what should we do next? Well, according to the condition of the problem, they ask for the largest integer value of the parameter a. The largest integer value of the parameter a will be only when this angle x is positive. So we must make the following inequality: 180 minus 8a greater than 0. So in this case, a is less than 22.5. So if we are asked for the largest value that is included in this interval, then this will be the number 22. The answer is 22. Problem 5. Square ABCD is inscribed in a circle with the center at O. PQ, the points of contact of the sides KL and LM of square AKLM with this circle. The radius of the circle is A. See figure. For what smallest integer value of parameter A does inequality PAKLM minus PABCD greater than 12 hold? PAKLM, PABCD are the parameters of squares AKLM and ABCD respectively. And so I have drawn a circle in front of you in which the square ABCD is inscribed. And also, according to the condition of the problem, we are given a square AKLM. So first, let's determine the side of the square ABCD. If we are given that the radius of this circle is equal to A and the diameter, it is always twice the radius. So BD is the diagonal of the square, and at the same time, it will be the diameter of this circle. I mark this diameter of the circle in green. So the sides of the square are equal, so I mark the sides AB and AD by X and highlight them in blue. Then by the Pythagorean theorem, we can determine what the side of the square is equal to. It is equal, after calculations, a root 2. Then the perimeter ABCD equals 4x, and if we have x equals a root 2, then the perimeter ABCD equals 4a root 2. Then let's find the side of the square AKLM. So the radius of the circle is a. We just found that the side of the square ABCD is a root 2. So half of this side is a root 2 divided by 2. And then we can find what the length of the side KL is. KL equals a root 2 divided by 2 plus
a.
And so the perimeter of the square AKLM is 4KL.
Instead of KL, we substitute the corresponding values and get that the perimeter of this square is 2a root 2 plus 4a. Then we write this inequality, which is given to us, under the condition that the difference of the perimeters of the corresponding squares is greater than 12. So we have just determined with you the perimeters of these squares. We substitute them into this inequality, and after the corresponding calculations, we obtain such an inequality that a is greater than 12 divided by 4 minus 2 root 2. We are already rewriting this inequality here, and we will simplify this fraction. In the denominator, we can take out the 2 and get 6 divided by 2 minus root 2. Then we can get rid of the irrationality in the denominator of this fraction. We must multiply both the numerator and denominator by 2 plus root 2, and we will get in the denominator the difference of the squares of the two expressions, and in the numerator, we leave everything as it is. Then, after calculations and simplifications, we will get that this expression is equal to 3 multiplied by 2 plus root 2. We rewrite this inequality again, and after the transformation, we just got such an inequality. A is greater than 3 multiplied by 2 plus root 2. Now, what should we do next? We should write root 2 as root 200 divided by 100. Now we look at the square table, and we understand that the closest number to 200, which will be less than it, is 196. So I rewrite this expression as follows, and I calculate it. It will be equal to 10.2. Therefore, A is greater than 10.2. The smallest number that is included in this inequality will be 11. This is our answer. So, if you understood everything today, I would give you the one villa as a gift. If you were worried or excited because you did not understand something, no problem. Watch this video again slowly. Never give up, and I wish you to understand it as soon as possible. Bye!